Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. No, don't adjust those computer screens or television sets there. I am wearing the same shirt and tie. I'm just on double duty today. 2 videos in one day. You kidding me? Whoa. Wow. And here's a special treat. You get to see my nice, perfect handwriting up there. Can you believe how distinctive and unique this is? Well, we have a base and a height up there, and that kind of leads us into today's lesson. We're going to continue to work with parallelograms, only today we're going to see, are there any families of parallelograms similar to what we did with triangles, with families of triangles? But we're going to use a base of 6 and a height of 4. I'm also going to let you in on another little secret. Mr. Lehner can't stand drawing parallelograms. I'm not a really good artist, and I don't like to do it, but I'm going to try my best, and guess what? You're going to get to try and draw some as well. So let's take a look at our grid paper, and let's see if we can draw out some of these parallelograms. I'm going to draw the first 2 parallelograms. See, it's even a tongue twister to say. I'm going to draw out the first 2, and then I'm going to pause it, or you're going to pause it, and I'm going to have you draw out 2 different ones with the same dimensions and see, can we make a family of parallelograms? Let's take a look. Okay, now I said that we needed to have a base of 6. So, similar to what we've done before, I'm just going to take my ruler and let's go 6 boxes across. 1, 2, 3, 4, 5, 6. Okay, so now I'm going to start with my line segment just like we did with the triangles. Now, I know it needs to have a height of 4, but when drawing this out, it's going to be a little bit different than a triangle. I'm going to kind of go almost on a diagonal. So I'm going to count up 1, 2, 3, 4, and then I have to go on a diagonal, so I'm going to make it right here. This is a height of 4 still, but now when I connect my line, it becomes a diagonal here. So it's not a perpendicular line like we've done with the triangles. Then I have to count across 1, 2, 3, 4, 5, 6. I'm going to put a point here. I'm going to connect this line here. And then lastly, so I can get it straight, connect my top lines here. And what do you know? Mr. Lehner is able to draw a parallelogram. Now I'm going to label it. This base, actually let's use the marker here. It has a base of 6 and a height of 4. Those were the parameters. Okay, now I'm going to draw another one here. I'm going to follow that same logic I did the first time. 1, 2, 3, 4, 5, 6. Okay, I'm going to count up again. 1, 2, 3, 4. And then I'm going to go 1, 2. I'm going to go 2 boxes in. So now I'm going to connect these 2 lines, because it's still going to have a height of 4. And then I have to count over 6. 1, 2, 3, 4, 5, 6. Put my point there. Connect these 2 lines right here. Connect those lines there. And again, now I'm going to have a base of 6 and a height of 4. Okay, so the one's going to be a little bit different. So what I'd like you to do right now, I've drawn 2 parallelograms with a base of 6 and a height of 4. I'd like you to pause this video, and I'd like you to try and draw 2 on your grid paper with your marker and rulers. Go ahead and pause the video. Okay. There's a couple different ways you could have done your parallelograms. So yours might not look the same as mine. All right, I'm going to try a different one here. I'm going to get a little bit out of the box. Let's see. Make sure I'm on here. Okay. 1, 2, 3, 4, 5, 6. And I'm going to go diagonal. 1, 2, 3, 4. Oh boy. And I'm going to count over 1, 2, 3, 4, 5, 6. I'm counting over 6 because the base is 6. So the reason I was counting, you see me counting over 6 spots, is because that base was 6 and the height was 4. That's how I know how far to go over when drawing my parallelograms. I'm even surprising myself a little bit here. This is still 6. This is still 4. And then let's draw one more out. If I was going to do another one, let's do it on this side over here. And let's do 1, 2, 3, 4, 5, 6. And I'm going to count up 1, 2, 3, 4. On the side there, let's connect these lines. Then count over 1, 2, 3, 4, 5, 6. We're getting close to the other parallelogram over there. And then I'm going to connect these lines on the side. Okay, I still have a base of 6 and a height of 4. Ooh, there's a little cut off there in the bottom. But our base is still 6 down here, our height is still 4. Now, what I want us to do is when we examine, we have 4 different parallelograms up here, but they all have the same dimensions. What I'd like you to do right now is to pause the video and find the area of each one of these parallelograms. Go ahead, pause that video. Okay, now that you've found the area of all 4 of these parallelograms, what conjectures can we make about these parallelograms? Do they create a fact family or a parallelogram family here? Let's find out. I'm going to find my area and see what I can come up with. Okay, I'm going to take a look at the first one here. Again, I'm going to notice that if I draw a line down here, I can cut away this part right here. So if I were to take this triangle here, I know I could fit it on this side. So I'm going to get rid of this one right here. I'm going to pretend it's gone. And count 1, 2, 3, 4, 5, 6. Then I'm going to count up here. 1, 2, 3, 4. So it's 6 by 4. So 6 times 4 would be 24 centimeters squared. Again, this first one I did the cutaway method. I decided to cut that part off of the parallelogram and add that triangle there on at the end to make it into a rectangle. Alright, let's do this one. We're going to do this one a little bit different. I'm going to create a giant rectangle around the outside. Okay? And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. It's going to be an 8 by 4. And I'm going to get 32 for right now on the side. But I know I have an extra triangle here and an extra triangle here. So I know that this triangle is a 2 by 4. So 2 times 4 would be 8. And then 8 divided by 2 is going to be 4. I know that this triangle is equivalent to this triangle here. So this is also going to be area 4. Since they're not part of the parallelogram, I have to subtract them. So 4 and 4 is 8. 32 take away 8 becomes 24 centimeters squared. So again, that was just a different method to use. Alright, let's try this next one, this next parallelogram here. Alright, let me draw out my lines here. Let's try a different color, maybe make this a little bit easier. Okay, I'm going to make my points here. There's my blue line. Yeah, it's a little bit easier. Okay, so now I'm going to count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say 10 by 1, 2, 3, 4. The height is 4. So that gives me 40. Now that's not my answer yet, but I'm going to work with it down here. So I know I need to find the area of these 2 triangles. 1, 2, 3, 4. This was 4, and this was 4. 4 times 4 is 16. 16 divided by 2 becomes 8. Same thing here. 1, 2, 3. This is 4 by 4. It's 16. 16 divided by 2 becomes 8. So now I had my area as 40, but I need to subtract off the 2 triangles, which is 40 minus 16, which becomes 24 centimeters squared. I think I'm starting to see a pattern. Let's try one more here. Draw my triangles here on the sides. Same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 4, which becomes 40. The triangle is 4 by 4. These become 8. Subtract them, and I wind up with 24 centimeters squared. And again, you may have drawn a couple of different parallelograms with the dimensions. You may have done a different strategy to find the area of the parallelogram. But what we notice is that they all have, what conjecture can you make? Yeah, they all have the same area. So we can find out that if a parallelogram has the same base and the same height, it's going to have the same area. And we just made a family of parallelograms. You guys did a great job in there. Go ahead and give yourself a nice pat on the back. Thank you for tuning in to Mr. Lainer's Math Extravaganza. As always, we'll see you next time, hopefully with a different wardrobe.